Wait a little bit more. Yes, welcome everybody at our AWS meetup in combination with some speakers from AWS. Very nice, and thank you for being here. So first, our first talk is going to be Oom. He's going to talk about event-driven architecture in AWS. Oh, that's your talk. Okay, then creating infrastructure with actual code. So give him a warm applause and take it away.
You see here, right? Oh, you don't see. This makes it feel like a live event. Yeah, when you. Yeah. All good? Okay. Good. So I'm Om. As you can see, I work at AWS. Hey, I work at AWS, and I'm going to talk about infrastructure as code. Right. That means infrastructure as code on AWS, obviously. Right. How you do that? How you create infrastructure on AWS. I'm working at AWS for last 3 years. Right. If you have any question in between, right, you can interrupt me. I will try to answer my best. If I'm not, my colleague is here. He will try to help me. Right. Okay. Some level setting before we start. Uh, if you are already infrastructure expert, right, it could be a little bit boring for you, right, because we are going to cover some basics. We are going to talk about basics, but at the end we are also going to see some code, right? So yeah, some level setting, some expectation, what you can expect from this talk. Okay, and apologies for delay, traffic, other things. Yeah, okay. So before we go into actual infrastructure as code, what is actual code, and uh, what we are going to do, and how people are doing nowadays, right? Let's talk about the history of infrastructure deployment, right? How it was happening, right? And I'm not going to go uh, like 20 years ago. I'm going to go into the AWS time, right? Because I said that creating infrastructure on AWS. So the very early time, if we go when a lot of company have just started using AWS, right? We say it level 0, right? So what most of the engineers or user of AWS, what they were doing, going to AWS console, right? Of course, if they didn't have account, signing up with credit card, getting access to AWS console and clicking here and there and creating the resources, right? Which was working very well, right? Because before that, if someone was developer, right, they didn't have access to any kind of infrastructure. They were like creating some kind of ticket, yeah, some kind of ticket or something, and some system engineers or DevOps, not DevOps engineer at that time, but some system engineers, they are creating those infrastructure. For developers, it was like, okay, yeah, now they can do it by themselves, right? And it was working good, working great, until people were experimenting with this or doing something simple, right? And it became challenging when people started creating little bit production kind of infrastructure, right? And wanted to do wanted to follow software development life cycle, so create multiple environments. They wanted to repeat the infrastructure. It wasn't possible. Right? It was possible, but there was like high scope of errors, right? Because you need to have runbook, playbook, and still there are human who are clicking the different button, typing the information, and there are chances of mistakes. So there is no guarantee that the infrastructure what you create on test environment, the same infrastructure will be created on acceptance on production environment, right? So, and so that is one challenge. But other challenge was uh, time it takes, right? If, for example, if it is a large enterprise company and they have to create, for example, nowadays one organization have like thousands of AWS account, right? And if they have to create, let's say every day infrastructure for different environment, it takes a lot of time, So what a lot of engineers, what they started doing that, okay, let's automate it, right? Uh, they had AWS SDK, right, since beginning. So there were AWS API, SDK, and what they did, basically created some shell script, some automation, right? Some command line and calling the SDK from there, right? So it solved the challenge, which was like creating the infrastructure by hand. That was solved, right? Because they were able to just uh, run or basically run deploy.sh or something, and then it was creating the infrastructure. But then they ran into different type of problem, and then those problems were like, what if infrastructure creation failed in between? There was no logic to handle it, right? What if you hit certain limit, right? You know, if you know in AWS, we have a lot of soft limit in the new account, right? Because you don't unnecessarily spend a lot of money by doing some mistake. So we have some soft limits. So what if you hit those limits, right? So those kind of handling were not done here in these scripts, and it was possible to do it, but again it is difficult. You have lot of edge condition, right, to take care of, right, and you have to keep it updated with the update of SDK and with the new issues, all those things, right? So it wasn't let's say enterprise ready. uh, so when the infrastructure of customers it started growing, then we realized that okay, now we need to have something there, and that's where we have launched what we say declarative infrastructure as code, right? And this is the place where real infrastructure as code uh, uh, started, right? Where engineers were basically writing real code for their infrastructure and deploying it to AWS account. So what declarative infrastructure as code means here, that they need to declare in some kind of text file, right? It is JSON file, YAML file, right? They need to define that what they need, right? What resources they want. They need to declare everything explicitly. And there was something like infrastructure as code provider, right? So we have AWS CloudFormation. That's a AWS service, but there are other solutions also like HashiCorp Terraform, which is our partner, which also offers infrastructure as code platform, right? So what we do here, that we define in some kind of text file that okay, these are the infrastructure what we are looking for, and we give it to AWS CloudFormation or HashiCorp Terraform. So any infrastructure as code provider who calls the AWS SDK, AWS API on behalf of you, right? So all the challenges which was there in the previous approach, imperative infrastructure as code. So all the handling, all the edge cases which you need, which was basically needed to handle in deploy.sh, now all those things are offloaded to these infrastructure as code provider, right? It is so basically CloudFormation, it's AWS service, right? If the AWS SDK is updated, they are updating the CloudFormation, that CloudFormation APIs, that okay, how to use those SDKs, and all the error scenarios, all the handling of those edge cases, everything was done there. Right. So here also over the time, people started not challenge, but there was some, let's say, you can say challenge, but there was like if the scope of infrastructure over the time it started growing, right? So let's say in the beginning it was like only 10 EC2 instances, maybe 5 BPC. So BPC is like a private network in the cloud. EC2 instance is a virtual machine in the cloud in AWS, right? So we say elastic compute cloud. So when the infrastructure presence, it started growing like from 10 EC2 instance to 1,000, right? Or 5 BPC to 100, 500 BPC, right? So it was difficult to write this CloudFormation template because you have to write a lot of code. Why? Because when you write CloudFormation template, because it is declarative, you need to declare each and every property. Right? If you're creating EC2 instance, so it's not like, okay, I want one EC2 instance, please create, I want one M5.large in this availability zone. It's not possible. You have to define like, this is the type, this is the size, this is availability zone, and not availability zone, but subnets. It is going to, if you want private subnet, then you have to specifically specify that. So you have to provide all the details. Right. So, and a lot of developers and a lot of engineers, they wanted to do it quickly. They did not want to spend so much time writing YML, right? So that was one challenge. Other challenge is that it is plain text file. It is JSON or YML, right? So it was working for some of the engineers, sysadmins, but the people coming from development background, right? And when DevOps practice, those things started, right? Developer doing ops work or ops people who wanted to do more programming, like in Python or other type of programming language, they for them it was not interesting, right? Writing plain YML, it wasn't interesting for them. So they needed something code, right? They wanted to write something in the code. So that's where we have created one more layer of abstraction, which I'll be talking about. But before that, I want to show one analogy, right? If it is infrastructure as code is let's say new for you, or you have not done it before, so you can compare it to a shopping list, right? So assume that you have hired a professional shopper, right? And to that professional shopper, you say that what I want every week or every day a dozen eggs, some milk, some bread, some carrot, or some vegetable, right? You say that, okay, this is the stock I want every day in my fridge or every other day. So what that professional shopper is going to do, go to your fridge or go to your stock, check what is already there, all right, and list all the missing items, and then go for shopping and only shop for missing item, and then you have your stock full. So they are not going to like you say, okay, I want all these things, and they are going to buy all those things, right? They are going to find only missing items and buy those missing items. This is what you can do exactly with CloudFormation, right? CloudFormation knows your state, knows the state of your infrastructure, right? That what is already created in your AWS account, and if you add something in your CloudFormation template, for example, you say that, okay, I have one S3 bucket, and I want one more S3 bucket. You add the code, you declare the text or code for that that S3 bucket, and CloudFormation is going to check, okay, there is one S3 bucket already, I'm going to create just one more. So what you see here, right? So the example, what I explained. So this is, what you see here is a simple code, and this is CloudFormation. This is how you declare S3 bucket. And it is going to AWS CloudFormation, and CloudFormation is calling the API and creating the bucket one. You go there and add bucket 2, then it is what it is going to do. CloudFormation is going to check that, okay, bucket 1 is already there. It is just going to add bucket 2. Same, if you remove something, then it knows that, okay, there is like 10 buckets created, and you remove 2 buckets, it will go just remove 2 buckets. You have some question? Yeah. If you speak a little bit loudly. Uh, Yes, yes. So when you create first time like CloudFormation stack, right? So it doesn't show in your S3 bucket, but under the hood, it keeps you the state of what infrastructure have been created. It uh, it like stores a table, right? Yeah. The table you don't have access, but it stores the information in some kind of storage, and where it knows that okay, with this stack, we have these many resources created. If you create some resources using CloudFormation, and if you delete it by going to AWS console without doing it in CloudFormation, it will show that okay, there is a drift. There is a drift means that what CloudFormation thinks that okay, we have created these resources, but some of them doesn't exist. Some of them are deleted. So it knows about that. Yes. Any question here before I go to the next one? No? Or or uh, do you all know about CloudFormation, or is this like you are hearing about it for the first time? You, sorry, can you come again? Hmm. Hmm. Yeah, so we don't have a state file here, right? We as I said that we store the state, but not in state file. It is not accessible, right? But what you can do, you can of course access the CloudFormation uh, console in AWS console, and you can see the list of resources, what is created by it. But you can also do it by AWS CLI, and then you can access all the resources, or you can get the list of resources created by this stack. Okay. Okay. So moving forward, so the next level of infrastructure as code, right? And that was infrastructure as code abstraction, right? What was done here is, as I have mentioned, that there were a few challenges with CloudFormation, not challenge, but like you have to write a lot of code, and as a developer, you don't want to provide all those details, which is probably not relevant for you. Right, so what we have created another layer of abstraction, right? And that is something we have called it AWS Cloud Development Kit, right? So I would like to compare it to the same shopping list analogy to explain that what this abstraction does, right? So imagine you go to a restaurant, right? And when you go to a restaurant, you say that okay, I want to eat some tasty dinner, right? Anything, right? So then you don't specify that okay, I want these ingredients, or these things. I want you to cook it like this, right? You ask them, and restaurant and chef, they know what ingredients are needed, right? They know how to cook, right? And they cook it for you. They do the shopping of resources, or shopping of ingredients, and then it prepares the dinner and serves the dinner to you, right? So what you have said in the restaurant that okay, I want tasty dinner, and as a result, you get tasty dinner, right? This is what this abstraction means, right? That you don't provide all the details when you are creating your infrastructure. You say that okay, I want EC2 bucket with this name, with this property, and you get it, right? What are other properties which are needed for CloudFormation to create those resources? Those are injected, those are added by this abstraction tool, AWS CDK. So how? Because in this CDK, we have abstracted many defaults. So many properties which you had to add in CloudFormation, this is abstracted by default value here. So default value means like from a lot of best practices, learning from a lot of other customers that okay, what should be the value for example, production ready VPC, production ready network, right? Based on that, all those default values are automatically provided when resources are created using CDK. Right, I'm going to show in the coming slide how CDK actually creates the resources. Right, it does it via CloudFormation. Right, it is not something it is doing it automatically. It does it via CloudFormation, and those default values are injected when CDK is translated into CloudFormation template. So quickly talking about CDK. So what it is? So it is a cloud development kit where you can write your infrastructure in actual code. And actual code means that you can write in those programming language, what you see here, in TypeScript, JavaScript, Python, Java, C#, and Go. You get all the capability of programming. So you can do unit testing, you can apply all those loop for everything what you do in normal programming, right? You can apply all those programming techniques when creating the infrastructure using Cloud Development Kit. So it has three part basically, right? So a core framework, construct library, and CLI, right? So core framework, where the framework on which you deploy, you write your code, you deploy your infrastructure. Construct library is where code is abstracted, right? It is abstracted in the form of constructs, and it is you can think of like in Python, in TypeScript, you have libraries for different SDK for different APIs. So similarly, these are libraries which are available in form of construct, and you can use them. And I will show you during the demo how you can do that. And CLI is the way you communicate, the way you use CDK, right? So you do CDK deploy, and it is going to communicate with AWS account and create resources there.
Thank you. So in the declarative version, you say, I need these components, and just like Kubernetes, it's going to look at the components, look at the state, and guarantee you that those components are there with that configurations, right? This is the declarative. What's the difference from the infrastructure as a code? I didn't get this.
From this one, CDK?
Yeah, the difference between the declarative and this one.
Okay. So the difference here is in the declarative ones, you had to declare everything, right, by yourself. You have to, for example, if you are going to create VPC, VPC is a network in cloud. So you have to, if you are creating a VPC, you have to define that, okay, what is the CIDR range? How many availability zone it should span, right? And then how you are going to create subnet, right? If you are creating a subnet, then route table, all those things you have to do yourself, right? But here in this CDK, you have to write one line of code, and you say that, okay, I want a VPC with 2 availability zone, right? How the routes are going to, how the routes will be created in the route table, this will be automatically determined by AWS CDK, right? Of course, you have option to overwrite it. You can say that, okay, no, I don't want the default options. I want to change it. You have the option, but if you don't provide those options, you get it automatically created and decided by AWS CDK.
You mean if there's a dependency, so VPC needs this, and this component, this is automatic. And also for the configurations, like we don't have to know which properties are needed. It's
exactly.
Like
mostly on the configuration part. So what it is going to do?
If I need to put these configurations, I can.
Yes, you can pass those configurations. So that is possible. But if you don't want to, then it is going to use the default configuration, which is done by CDK, right? So what it does, that it is not like there is just default value. It has been created in such a way that it puts the smart default value as for the configuration parameter. Yes.
Thank you.
So I'm going to show you how the workflow is, right, and then it will be a little bit more clear. So what you do here is that you write your source code in AWS CDK using the CDK library, right? And what then you do, that you use CDK CLI, because CDK CLI is the way to interact a way to create resources using AWS CDK. So you go to CDK CLI, do init, right? If you're using TypeScript project, then you are doing some normal build and compilation. And then there is an important command, which is CDK synth. And what this command does, that it translates your AWS CDK code into CloudFormation template. So what AWS is, AWS CloudFormation engine, basically CloudFormation engine is receiving is actual CloudFormation template, not CDK. So CloudFormation engine knows CloudFormation template. CloudFormation engine doesn't know about CDK, right? So what synth does, it translates translate the TypeScript code or JavaScript code or Java code into a CloudFormation template, and that's when it inserts all those default values. So when CloudFormation template is generated, that will be a full template, right? But CDK, yeah, you don't see all the details there. And then, so as you see here, that the template is generated, and that template is provided to CloudFormation engine, and CloudFormation engine is then going to AWS account, and our CloudFormation engine is actually in AWS account. So what it does, that it creates resources for you. Okay, let me go back. I wasn't looking at the screen. So yeah, so with CDK deploy, you have your resources created. So what you see here is an example of construct, right? What you see here, new CFN bucket and some detail about this, and then you see the CloudFormation template generated, right? Now there is a level of abstraction, right? So there is L1, L2, L3, right? What is L1? L1 is what we say L1 level 1 construct. It is one-to-one comparison of CloudFormation resources to CDK code, right? So for every resource, like for example here, what you see, the type AWS S3 bucket, there will be one construct or one class. If we take example of Java, one class available in AWS CDK, right? It is one-to-one mapping for all the CloudFormation resources available. So if you use L1 construct, so that means that you have to provide all the details like you do in CloudFormation template. But the only benefit what you will get here, that you will get the option of like writing your infrastructure in code, right? Instead of writing it as a YML or JSON, right? But you have to provide all the details, right? So this is what we say L1 construct, right? So let me go back. Yeah. So take this example of virtual private cloud, right? We have been talking about VPC a couple of times. So if you have created a VPC before, right? And if you not, so when you create a production ready VPC, so what kind of things you need to create? You need to create first, of course, VPC. You need to create subnets which span across multiple availability zone. You need to create internet gateway. You need to attach it. You need to create NAT gateway in multiple subnets. You need to create route table, which you don't see here. And you need to create multiple routes. You need to configure that how traffic is going to go from one subnet to another subnet and to internet and from internet to your network, right? And if you create it via CloudFormation template, right? Just one production ready VPC, you need to write 270 lines of code, right? Yeah, you don't see it here. Yeah, it can be 272, 275, depending on how much comment you add to your code. But yes, if you have to define a production ready VPC, you need to write 270 line of code. Same thing in CDK, same production ready networks, same production ready VPC, you can do with just one line of code. And this is where the abstraction happens, right? This is where we have abstracted everything, right? Like your question that if it is possible to provide parameters or configuration parameters or not. Here what you see that yes, this is possible. Here you can provide, you can override that we want maximum AZ true. If you don't do it, then it will automatically take 3, right? Any question here? No? Yeah. Yes. All the programming. So that's why we have added a programming capability, right? That with the programming capability, as much as yeah, programming. You can leverage, you can embrace as much as programming concept there, yes. So for example, I can give you an example that, okay, you want to create 3 instances, but of 3 different type, right? Or 3 different size. For example, M1, C1, or R1, right? What you can do, you can create a list, or array of these 3 string. You can create a code, you can loop through that array, and you can pass the instance type or instance size as a parameter, right? Yeah. For example, here, if you have to create, let's say, 10 BPC because of requirement, right? And each 10 BPC has different max AG requirement. Maybe the test BPC just 1 AZ, development 1 AZ, and production or other type of application different. So what you can do, you can loop through, you can create a array list of like AG size, right, or expected AZ, whatever you give the name of that array, and you can loop through it. You can call the same code 10 times, just change this value. Right. It will create 270 multiplied by 10, so 2700 lines of CloudFormation code. So it will be generated. Yes. Any question? No. So this is where the abstraction begins, and at this abstraction, what we call is L2 construct, right? And what L2 construct is, right? Like L1 construct, we have one-to-one mapping of each CloudFormation resources, but for L2 construct, we have created it for like each service, right? It is not like that. Okay, it is available for each and every let's say every newly launched service, right? But it is available for most of the service, right? Like for here, you see BPC, right? BPC is part of EC2, right? If you have done a lot of CloudFormation, then you know that BPC is part of EC2. So EC2 is available as it is called AWS -EC2. The name of that construct is called. And then for S3, AWS -S3. For Lambda, AWS -Lambda. For API gateway, AWS -API gateway. So for each those services, we have created L2 construct, and these constructs are created by AWS, right? We have made those available, and you can consume those constructs like this. You can import in your code, and you can start using it like this. So for most of the service, we have L2 constructs available, and this is where abstraction is applied. So this one line of code, just to explain what is listed here, this one line of code is going to create a production-ready BPC with these many IP addresses, more than 65,000. 3 AZ, and as it is mentioned that everything is optional, you can override it. But then after that, there is L3 construct, right? And L3 construct, as I said, that L2 construct are created by AWS, right? But we have made this AWS CDK is open source project. We have made it available for community, right? And what we have asked our community that, okay, create a pattern based on your uses, based on your requirement. For example, if we look at this example, let's assume that there is a company who is deploying container on ECS Fargate. ECS is a container service on AWS, and Fargate is a serverless compute. And they have one application which is running on container on Fargate, and which is in the front there is a load balancer, right? And because of multiple reasons, could be that okay, they have multiple environments, they want to create those applications many times, right? They want to repeat the infrastructure for that application, let's say during CI/CD pipeline, right? First create the application and then do the testing and then destroy it, right? So they can create the pattern, they can abstract even more, right? So what you see here at L3 construct level, there is one ECS pattern which is created. What it says that application load balancer with Fargate service. And some details are provided here, right? And there is a information about container image, sample image. And what it is going to do, just this 6 lines of code, it is going to create a production ready VPC, what you have seen before, elastic IP, all those things, then elastic load balancer, security group, ingress, egress rule, the task definition. Task definition is something, the detail of your Docker container, that how it is going to run. Listener, then target group, and then some security related stuff, IAM group, IAM policy, log configuration, and then also image, CPU, memory port. All those things are done with just these 5 lines of code, because with this in this pattern all the details are abstracted at one more time, right? But this is let's say very specific to your use case. It is not like okay, it can be used in all the use cases, right? If your use case is using a service with application load balancer running on Fargate, then you can use this pattern, right? But if you want to have a network load balancer, or if you want to have some other not a load balancer there, right? You want to have like just running just running as a like doing a bad job, right? Then you have to use the L2 pattern, L2 construct. Any question here? Yeah. 8 to 9. I just wanted to show you here that if you do a lot of container related application, right? Then you have experienced even on AWS or on premises everywhere, right? Running container on production is a lot of work, right? And this AWS CDK, it is not only infrastructure as code. It goes a little bit beyond, and you can use it in your, let's say, application development as well. So application development, by saying that it ties to your application code as well. How it does, right? If you see here, there is a L2 construct, AWS ECS, AWS Elastic Container Service, right? And what this second line is doing, this second line is saying that create a container image from the code available in your local, available at your local machine. So for example, inside the apps directory, you have your Docker file defined, you have your code, for example, mycode.js, which is available there. What this single line of code is going to do, it is going to take the code, Docker file, this code, do all the building of the code, compilation, whatever required. Then it is going to build the image, and once with the Docker build, once the image is built, it is going to publish that image to ECR. ECR is Elastic Container Repository, right? And it is going to create the repository, right? If repository is not already there, so it is going to create the repository and then publish that image there, right? So with this single line of code, you can do building your local code, building Docker image, creating your ECR, and publishing the image to ECR. Right. And recently, we have created some more extension, more libraries to this. And what we have we gave it a different name. We said it AWS CDK containers to simplify the container deployments even more, right? Because we know that running container on production is very difficult, right? You have to do a lot of work, right? So with this extension, AWS CDK containers, and what we have said, it's service extension. What you can do, you can take that code from your local machine and directly create a service. So once you have created an image, and that image is available in ECR, you can directly create a service from there, and that service will be, and you can access those services. Right? So with this line of code, these lines of code, what you can do, here you can create a service description, and you can provide that, okay, how much CPU, memory, some traffic related information, and then you are going to give the information of image and just provide environment and service description. What it is going to do, it is going to create a traffic port 80. So it is going to create a publicly accessible service, which is if your container is of course returning on port 80, then you will have an API which you can directly start accessing. So everything under the hood, like creation of service, creation of cluster, creation of task definition, creation of task, all those configuration will be handled handled via abstraction. Any question? No? So where you can find those constructs, right? You can find those constructs. We have on AWS website. If you search for AWS solution construct, you can find all those L2 construct, but you can also find L3 construct. And a lot of L3 constructs are created by us as well, by AWS, and it is available as a pattern. And what you see here, like, okay, you want some CDK code or CDK pattern, which is like connect API gateway to DynamoDB, or API gateway to Lambda, or API gateway to SQS. Right? You can get that pattern, you can deploy it, and you have that solution running in your AWS account. You can also find this on Construct Hub. Construct Hub is a constructs.dev. It is a website, open source from community, right? And you can go there. You can find all type of constructs there. L1, L2, L3. A lot of documentation and everything is available there. So this is what I had in presentation. So if you want to see some code, I'm not sure if it, I think it is visible. So let me go from here. Is it visible or? Okay. So this is the code. What you see is to create an EC2 instance on AWS. EC2 instance is a virtual machine, right, which runs in the cloud, of course. With this simple code, what you can do, you can create a new network. What you see, you are familiar with this code, creation of VPC, and then creation of instance, and you are going to provide some mandatory parameter, mandatory value like instance type and what AMI you are going to use. AMI is like machine image, right? And with this line of code, you can create EC2 instance, right? So you only provide the necessary details and it is there. Any question on this code? It is the simplest one. No? Okay. Then I have other code, which is an example of an API, and which is like the API which is served by a Lambda function, right? And when you call that API, it is going to just count the hit, right, on your website. So how many times you call it, it is going to say, okay, this is the hit counter. With this line of code, what you see here is what we are doing here is creating a Lambda function. And what I have mentioned that it ties to your local environment, local code as well, your application code as well. So what I'm saying here, that take the code from this Lambda directory. Yes, so here there is a Lambda function. What you see here, this is a Lambda code, which is a very simple code, which says, okay, yes, you have a hit. There was a hit. Okay, and what it is doing here, that it is with this line of code lambda.code from asset, it is going to take everything, whatever you put in this Lambda directory. Currently, there is just hello.js, but what it is going to do, it is going to take all the code, make a zip, upload to AWS console, all right? AWS Lambda, not console, upload to AWS Lambda. That code will be, if there is a Lambda function already created, that will be updated during CDK deploy. And yeah, you see the information that, okay, it will be Node.js environment and hello.handler. And once this Lambda function is created, it is attached to an API gateway. And what you see here, new API gateway, and then Lambda REST API and giving some information. So it is going to create API gateway, and it is going to create connection between Lambda and API gateway using the REST API. All right, and then as a result, what you will have, you will receive one endpoint, and that endpoint you can access. Yeah. And that endpoint will call Lambda function. And a little bit more complex one, and this is the last one. If you are deploying a container, right? If you want to deploy container, right? So to deploy a production-ready container, how you can make use of what you see here is ECS service extension, which we have created to make the container deployment easy. You can take some, what you see here, that some high-level classes are imported, like service description, and then there is environment created here, which says like, okay, this is a production environment, nothing fancy. The important one is this service description. So there is a hit counter description, and here you provide details of your how your container is going to run, CPU, memory, and reference to your container image. And then here you see that I'm also adding a DynamoDB table. So connection to the DynamoDB table to the container will be made by CDK code, right? And here what you see is that what I'm doing, I'm adding an extension. So I'm saying that, okay, the container infrastructure is ready, but I want to access it using load balancer. So what I'm doing, that adding HTTP load balancer. Similarly, you can add X-ray extension, right? So if you know about X-ray, X-ray is what do you do with X-ray? I forgot the term. Tracing, yeah, of course, X-ray. So if you want to do the tracing from your load balancer to your Lambda code to the database, right, you can simply come here, you can attach X-ray extension, and what it is going to do, it is going to modify your container, right, automatically. Whatever is needed to make the X-ray configuration, make the X-ray running, it is going to make all the changes inside the container, and your X-ray will be enabled. Similarly, if you want to do CloudWatch, I hope there was for, let me see. So if you want to do CloudWatch, enable CloudWatch agent, right, you just need to go and add this extension. And again, it is going to make changes in infrastructure, changes in container, install the agent, right? Create a route that how the logs will be transferred from your container to CloudWatch, everything will be handled with this one line of code. So it's not only limited to these extensions. There are more extensions, but like we have done with CDK, we made it available for community that you can create according to your need. So same thing is also possible with extension. If you have your own need, you can create your own extension and you can attach like this. I think this was it. Any last question before he kicks me from here?
Yeah, very interesting article. So I have probably two questions. The first one is about, let's say you have a CDK code, yeah, and you want to apply to your AWS system. Which role you are using for that? You are using root or you are using like a IAM role?
Yeah. A root, once you never access root.
Yes, you should not use root.
Let's put it like this, right? You never access root. You create your root account, you put the password, maybe you cut it into multiple pieces and you put it at multiple places, right? What is the normal way of accessing, right? And what was, right? IAM user, right? You create IAM user, right? You attach some policy to it, right? Policy defines what you can do, right? For example, admin policy, you can do everything. You can also, let's say, scope it to let's say only S3 or only network or only serverless API gateway Lambda. So that was another way. But now enterprises they use role, right? And usually with most of the enterprises, when they use it on production grade, what they do, they connect it with their Active Directory. So the way the email address, what you use to log into other application in your organization, same email address and same password you use to log into AWS account. So what happens, that there is integration created in IAM, right? And with that, it assumes the role. So how you should do in production, right? If you are going to use CDK, assume role.
Okay. I see. And also the second question then.
I see Vincent wants to add something. Yeah. Yeah, of course, yeah.
And also then second question is about, for example, if my role doesn't have such kind of permissions, yeah, for example, to create some of the services and it's executing in code, for example, what's happened?
It will fail.
Okay, so there is some kind of exception.
If you don't have permission, for example, if you're creating a VPC and then role you are using to deploy your CDK code, right? And it doesn't have permission to do anything with the network, right? It will throw error that okay, not sufficient.
And it will roll back all another changes then.
Yes.
Yeah? Okay.
So in any stack, like in CloudFormation, if you create a stack, if stack creation fails in between, right, what it does that it automatically starts rolling back. So under the hood of CDK, so CDK doesn't create a stack by itself. What it does, the only job it does that it translates into a CloudFormation template and hand over that CloudFormation template to CloudFormation engine. And CloudFormation engine is basically creating that stack, creating those resources. So like in CloudFormation, if it fails, it rolls back. Yeah.
Okay, it's based on the CloudFormation.
Under the hood, all the creation happens with CloudFormation.
Okay, thank you very much. Yeah.
Any further questions?
No? Okay.
Then it's time to give another warm round of applause.
Thank you very much.
Some drinks.
Interesting topic about event-driven architecture, yes.